Good morning to all. Myself is Dhivagar. Now I am going to talk about asynchronous sequential circuits. These are the asynchronous sequential circuit. One is the analysis of asynchronous sequential circuit, design of asynchronous, and reduction of state table, flow tables, race-free state assignments, and asserts. These are the asynchronous sequential circuits. And now we are going to talk about introduction for asynchronous sequential circuits. In the sequential circuits specified by the time of by a time sequence of inputs, output, and input terminals are internal terminals. The output of the clock output changes in whenever a clock pulse is applied. The memory elements of the clock flip-flops. The asynchronous sequential circuit do not use the clock pulse. The memory elements in the asynchronous sequence is either unclocked or time delay sequence. First, this is the race conditions. Race conditions means said to be exist in an asynchronous sequential circuit when two or more binary state variables changes in input. The response to change in the input variables. We have the two races types. Two races are classified into two types. One is non-critical and critical races. The non-critical races. This is the non-critical races. It is the final stage. The critical circuits does not depends on the order in which the state variable changes from change the races is called non-critical races. For example, the possible transition is for input variable 0 0. The transitions is 1 1, and another state is 0 0 to 0 1 to 1 1, and third possible state is 0 0 1 0 1 1. These are the final states of the non-critical rates, which results the transition table starts with the total stable states y1 y2 is the and x is y1 y2 is the column, and x is the row variables equal to we can choose 000. The state change from 0 to 1. The variable state must change from 0 to 11. This is the race condition. We are already seen that 0 to 11, 0 0 0 1 1 1 0 0 1 0 1 1. This is the non-critical races. This is the possible transition or non-critical races, and next one is critical races. Critical races. This is the critical races for transition. The first critical races means if the correct next values of the next state values not reached during the state transition, if it is possible to end up in two or more different stable states depending on the order in which the state variable changes, it is called critical races. For example, state table y1 y2 and x equal to 0. The state changes from input 0 to 1. So the state variable changes from 0 to 1 1. The simultaneously 111 is the final output of the critical races. 0 0 1 1 0 0 0 1 0 0 1 0, and another possibilities is 0 0 1 1 0 0 0 1 1 1 and 0 0 to 1 0 is the possibilities of critical race statements. And next one is cycles. Cycles. This is the cycle best example. Three tables are used: stable transition and unstable state. Cycle means it can avoid by directing the circuits through the intermediate unstable state with the unique state variable changes. When the circuit goes through a unique sequence, unstable state is said to be a cycle. The cycles, if a cycle does not terminate with the suitable state, the circuit will keep the going. Circuit will going from one unstable state to another entire circuit unstable state. These are the possible, the main examples of the cycle state. For example, 0 0 0 1 1 0 1 1 1 0, and next possibilities is 0 0 0 1 1 1. Third possibility is 0 1 1 1 1 0 is the possibilities of cycle. These are the cycles races. The basic steps for asynchronous sequential circuit. After that, asynchronous sequential circuit race cycles and race free state assignment is hazards. We discuss about hazards in next topics. Okay, thank you all.